The third trend we're going to look at is electron affinity. The first trend was atomic radii. The second trend was ionization energy. Now the third one is electron affinity. Well, electron affinity reflects the ability of an atom to accept one or more electrons. How I remember electron affinity is A affinity, so you have A accept. Another way you can think of it is you're adding an electron. Energy change that occurs when an electron is added to a gaseous atom. So for example, here I have fluorine and I'm adding one electron to it. It turns into F-. When it turns into F-, the energy change, which is known as delta H, is negative 328 kilojoules per mole. This is an exothermic process. This means it releases heat. We will talk about this in Chapter 8. So a large negative electron affinity means the negative ion is more stable. So for example, if you have negative 328 kilojoules per mole versus negative 100 kilojoules per mole, which one is going to be more stable? This one. So this will have a, this one will be more stable, basically. More stable. Let's look at the trend for electron affinity. First of all, let's look at our axis. The y-axis denotes electron affinity. So as we're going to be increasing as we go up, increasing in negative charge. So what does that mean? That means that the ones up on top are going to be more stable, meaning that these are going to want to add an electron. So atoms will want to add an electron. The ones on bottom, what does that mean? Down here means atoms will not want to add an electron. Okay, and then we have atomic number on the x-axis. Let's look at a couple of these, couple trends. So here we have helium. Let's look at neon as well, argon, krypton, and xenon. What do you notice about the electron affinities here? These are going to be, or these will have very low electron affinities. I'm going to denote it as EA. Why do you think these will have very low electron affinities? These are going to be noble gases. And noble gases are going to be very, very stable. So noble gases, and they have a full shell. They don't want to add an electron because that would ruin their full shell. Okay, now let's look at these other ones. Let's say beryllium, calcium, magnesium, strontium, and barium. We would notice if we looked at this figure that these also will have a low electron affinity. Why do you think that is? These are going to be part of group 2A. Group 2A has a full subshell. The full subshell is S2. Again, if they add an electron, that's going to ruin their full subshell, so they would rather not add an electron at all. Okay, now let's look at fluorine, chlorine, bromine, iodine, and acetine. We would see that these have very high electron affinities. Why do you think they would have very high? These are going to want to add an electron, because if they add one electron, then they are going to be known as isoelectronic with a noble gas. Isoelectronic means it has the same electron configuration. The reason why they want to have the same electron configuration as the noble gases is because noble gases have a full shell. Now let's predict the trend for electron affinity. We had seen that halogens will have a very high electron affinity. And the reason why is because they really want to add an electron. If I look at group 1, do you think these will have high electron affinity or low? These will have a low electron affinity because if you remove one electron from them, they become isoelectronic with the noble gases. So we're going to be increasing from left to right with electron affinity. Now if I'm looking down a group, let's say I'm going to look at fluorine. Fluorine is going to be fairly small, right? If it's fairly small, that means that the electrons are more tightly held together. Okay, now if I look at acetine on the other hand, acetine is going to be bigger. If it's bigger, that means the electrons are less tightly held. Now, which one do you think will have more of a dramatic effect if it gains an electron? Something that's small or something that's big? You kind of want to think of someone who, like a small person versus a big person. If a big person eats a donut, so you're like adding an electron, it doesn't really care. I mean, it does care, but not that much. If you give a skinny person a donut, then it's a big deal, right? So we are going to be increasing as we go up a group. So fluorine will have the highest electron affinity. Fluorine really, really, really wants to get an electron. Acetine is like, I mean, it definitely wants one, but it's not a big deal if it gets one or not.